Hello, Matt G4IYT here, and today we're looking at the full mock examination number 1, version 1.6, and we're up to question 9, which is the relative permittivity of a dielectric is a measure of the A, dynamic resistance of a series tuned circuit when it's fed with a signal at the resonant frequency, B, amount by which the core of a coil affects the inductance when compared with the inductance in a vacuum, C, change in capacitance compared to a capacitor of the same dimensions in a vacuum, or D, amount of voltage permitted on the plates of a capacitor when fed by a rectifier diode in a power supply. Well, we should recall that a dielectric is effectively an insulator, and it's part of a capacitor, so we can immediately rule out that the series tuned circuit, no, it's nothing to do with that. It's also nothing to do with inductance, although there is a similar term which is permeability, which does apply for coils and inductance, but we're talking about permittivity. Okay, so we're left with the two answers which are about capacitors. So let's flip over to the full license manual and see what that has to say about capacitance, and it describes capacitance being composed of, it depends on the area of the plates of a capacitor, their separation, and the material between them, which is this K constant, and that is the permittivity. So there are two parameters that form the permittivity. There is this Greek symbol, I think it's epsilon, which is the permittivity of free space. So permittivity of an absolute vacuum with nothing in between it, and then we add this multiplier, this relative permittivity, to describe a particular material. So a vacuum therefore has a dielectric constant or a relative permittivity of 1. Air is fairly similar, it's also about 1. And then other materials such as paper, polythene, mica, and ceramics all have different dielectric constants or relative permittivities, and those characteristics can be used to build various capacitors of different values with other characteristics which may be useful to radio amateurs or otherwise. So we know now that it's nothing to do with the voltage permitted on the plates of a capacitor. That is in fact, you call that like the peak inverse voltage maybe with a rectifier diode, but I'm getting sidetracked. It is in fact the change in capacitance compared to a capacitor of the same dimensions in a vacuum. Remember we talked about the permittivity and the relative permittivity. So let's skip down to the answers, and number 9 we selected C, and there we go. C is the correct answer. Thank you very much. I'll see you in the next one.